told there may be a few that are anxious about having other commitments at 5 o'clock, so I won't drag on like I did the last time and keep you a little later. So we'll get through, don't worry. The next part is circadian rhythm abnormalities. This is something that you'll encounter, may not remember, and probably end up looking it up in a book and be like, dang, he taught us about that and I should have caught that. But so when we look at circadian rhythm, this goes back to what I talked about in the beginning with your whole retina, melatonin system and so forth, and how we can shift that phase doing inappropriate things such as watching TV late at night or devices in our face and these kind of things. But there are also age-related components that can play a role in this. So as the brain ages, the main thing that reduces when it looks at sleep, your delta wave or slow wave sleep stays kind of pretty much the same. The test question is that which stage of sleep diminishes as we age, and it's rapid eye movement sleep. You get less REM sleep as you age. But when we look at circadian rhythm disorders, I'll run through them. Some of them just are, oh yeah, that makes sense, and others are like, ooh, I don't know about that. But advanced sleep phase, it's exactly what it means. Somebody's advanced their phase such that they're going to bed earlier than what would be considered a normal sleep time. So let me give you an example. 84-year-old woman who lives in the assisted living facility comes in and tells you, I just wake up every night in the middle of the night at 3 a.m. and I just can't go back to sleep. And you've screened her for mood disorders and all this other kind of stuff. And so you ask her, well, Miss Jones, when do you go to bed? 7 p.m. Because we eat dinner at 5:30 and then I go lay down. Okay? I take my night meds. So we've gone to bed at 7, to 8, to 9, to 10, to 11, to 12, to 1, to 2, to 3. She's had 8 hours of sleep. What have we done? Over time, she's advanced her sleep phase to where she goes to bed earlier and gets up earlier, but she's getting an adequate amount of sleep time. So this particular patient has an advanced sleep phase. These are very difficult to treat. And most of the time, you just leave them alone and reassure them that either A, you're going to get up and drink your coffee at 4 a.m. and read the newspaper and take you a little nap later on, or you're going to work to stay up a little later at night. Now, if Pat Sajak was on or something they really liked, they'd stay up a little later, but they're not. So that's your classic advanced sleep phase patient. Your elderly folks that go to bed really early, wake up early in the morning, claim to you that they have insomnia, and they're getting an adequate number of hours of sleep if you look at sleep diary, and it's because they've advanced their sleep phase. Delayed sleep phase. The quintessential teenage brain. I prefer to go to bed between midnight and 2 a.m. and get up between 10 and noon. That's the normal teenage brain. Anybody in here have teenagers? Anybody in here used to be a teenager? Anybody in here still a teenager? Oh, dang. Okay, so it's not abnormal in the teenage brain to want to do that. Go to bed between midnight and 2 or 3 and get up between 10 and noon. I mean, that's the normal teenage brain. It doesn't become a disorder until it starts impacting day-to-day function, work, school, those kinds of things. So why is it a delayed sleep phase? Because these folks are choosing to go to bed much later at night. They get an adequate number of hours of sleep, but they're sleeping well into the day. It's not uncommon that folks that had delayed sleep phase that never worked through it or out of it are third shifters or second shifters. They choose to work shifts that fit with their sleep pattern because that's just how their brain works. Delayed sleep phase is a little easier to treat, and we have to slowly march their phase back by using bright light therapy in the morning to activate the retina, the suprachiasmatic nucleus, winding the clock more appropriately, and then we shift their bedtime back slowly at a time. You can't shift their bedtimes more than 30 minutes or you'll screw up the entire system. You're probably never going to have to try to phase shift somebody. We do it. It's very difficult. You have to use what a device called a light book, which is a blue wavelength light book that they carry around with them for the first hour of the day. And then we use melatonin and other sleep aids at night to try to get their shift back on. But just know, advanced is your quintessential old person, going to bed really early, getting up really early. The late sleep phase is your teenage brain. Jet lag, it's exactly what it sounds like. You change time zones, your brain is messed up. I fly from New York to California, and I'm changing every time zone we've got in the US. And now my brain is on New York time, and I'm trying to live on California time. And so basically, it's as you've moved west to east or east to west, then your brain is going to try to have to deal with that phase shift. Shift work sleep disorder. Folks who have their sleep interrupted because of the shift that they have to work. So it may be your donut shop owner that gets up at 2 a.m. to make donuts because they open their shop at 6 to sell donuts till 11. Maybe somebody that works the third shift at the local tire plant. Maybe a new mother. Parents are shift workers, in my opinion. Okay? So these are patients who, because of their work activity or other home activities, have an altered pattern of sleeping because of whatever that shift is that they're working. Free running, this is basically folks that sleep all different times and are awake at all different times. And these are some people who will basically delay their sleep phase until it comes all the way back around 24 hours, and then they'll just keep doing this. And they're just all over the place. These are very difficult patients to see. Oftentimes you'll see them in certain addicts, you'll see this, certain psychiatric disorders you'll see this, but some folks just have an unentrained sleep pattern. This is also called unentrained. And then an irregular sleep pattern, again, these are kind of people that will just kind of be all over the place. But the difference when you're looking at free running and irregular sleep patterns, people who are blind don't have the same activation system working, so their sleep patterns are going to be off because of that. We know that dementia patients and children and adults who deal with mental retardation will also have significantly impacted sleep patterns. And so those are just things to take into consideration when you're dealing with somebody with a weird, you give them a sleep diary, and you can download a sleep diary online that basically you can see their stuff is just all over the place. And these are very difficult people to deal with. Most of them really aren't working or will contribute much to society, either A, because of their medical condition, or because they just can't be on a regular sleep-wake pattern. So I'm not going to go through all the definitions, but I put the definitions in there so that you all would have them, just what the International Classification of Sleep Disorders says about the late sleep phase. I put the treatments in there solely because these are difficult patients to treat. We in sleep specialty actually kind of cringe sometimes when we see some of these circadian rhythm folks because they're very, very difficult. But the answer to treating delayed and advanced sleep phase folks and jet lag folks, it's all bright light therapy and melatonin timed at the correct times. That's what it's all about, is melatonin supplementation and bright light therapy at the correct times. Advanced sleep phase, just the definition, and again, you're dealing with light and melatonin. Jet lag, eastbound or worse than our westbound, because westbound you're gaining time, eastbound you're losing time. So that's why it's more difficult there. Again, treatment, you're dealing with bright light therapy and melatonin supplementation. Shift work, just the definition of, we can use bright light therapy in those folks as well. So there's a pattern. All of your circadian rhythm disorders, what did we talk about in the very beginning with circadian rhythm? It was light and melatonin. What's the treatment for all of these? Light and melatonin, okay? let's not talk about that yet. You don't need to know that one. I already told you about blind folks. I'm trying to make it to where we get out of here. Irregular folks. This is your dementia, your mentally retarded folks. They just, that's probably not the correct term anymore. Mentally handicapped patients. They have an irregular sleep-wake pattern, and you're just know it's going to be there. You're not going to be able to treat it. Let's do orexin hypocretin. Any questions about sleep up to this point? No? Y'all are sleep experts? It's only taken me 10 years to get this far. Orexin hypocretin, I mentioned that earlier. So these are the same chemical. These are not different chemicals. These were different names given to the same exact protein receptor complex and protein discovered simultaneously in different parts of the world. They discovered them through study of narcoleptic Dobermans. So there is a subset of Doberman that has narcolepsy. There are also narcoleptic goats. And I know that instead of listening to me, some of you are Googling things back there, and you can look up YouTube and there are narcoleptic goats. And so these animals that have narcolepsy, they are prone to cataplectic events. So narcolepsy is just an excessive sleepiness syndrome. Okay? Cataplexy is an abrupt sensation of muscular weakness in response to an emotionally charged event. So this can either be a pleasurable event or a scary event. Well, they found these narcoleptic goats and Dobermans because you would scare them and they would just flop over. And so they had cataplexy, and then they started looking at what is deficient in these animals' brains and or spinal cords and or spinal fluid. Why is it that they have these symptoms? And two sets of researchers simultaneously found the same thing, and they named them different things. Somebody can have narcolepsy without cataplexy. I have had one case of what we call clinical cataplexy without narcolepsy. I don't know that I can believe her, but I don't see her anymore. And I have seen one case of clinical cataplexy without narcolepsy. Although the Hollywood has done a great job of dramatizing narcolepsy and cataplexy, it really doesn't work that way. When you're interviewing somebody that may have cataplexy, you're basically just asking them, do they ever feel weak after an emotionally charged event? And it's not the, ooh, I scared you and you fell over like the goat does. Normally, in cataplectic patients, it's laughter that they will succumb to laughter, and they will feel very weak and they will want to go sit down or lean up against the wall or something of that nature. It's very rare that you will run across a patient that has such profound cataplexy that you tell them a funny joke and they're laying on the floor. That's just Hollywood. That's just not really how it works. But cataplexy is a muscle tone disruption because of an emotional onset, and that's cataplexy. So orexins or hypocretins, two different folks discovering them basically at the same time, not all that long ago. So this is an early in its early ages of trying to figure out what's really going on with this orexin. One of them called them orexin A and B, the other one hypocretin 1 and 2. They're basically G-coupled proteins. You all thought you'd never have to jack with that again, did you? These are G-coupled proteins, they are. So orexin, the peptide itself, has a much higher affinity for orexin 1 versus 2. You don't really have to know that. There's chromosomes that have been matched for all of that. But looky here, some of my favorite stuff again, neuroanatomy. So we know that there are a plethora of neuroanatomical pathways that deal with arousal. And this is awake arousal. So we have the reticular hypothalamic cortical pathways, reticular thalamic cortical pathways, and you're using all kinds of fun stuff. So the ventrolateral preoptic area, the ventral periaqueductal gray, you have dorsal raphe nucleus, the locus coeruleus, all of our fun guys that we were dealing with our pleasure pathway. Well, look, those guys all have to do with our arousal pathway. It makes sense that they would be together, because when we use a lot of those substances, they're very activating chemicals. And so they activate pleasure parts of the brain, as well as they're activating other areas of the brain that help with alertness, awakeness, and so forth. So although earlier we classified it as the best slide you've seen so far, this is the best slide you've seen so far today. What this really shows you is that we are in the early stages of some groundbreaking data on the whole arousal pathway in our brain. And that we can use drugs that deal with acetylcholine or acetylcholinesterase inhibitors, or dopaminergic drugs, or noradrenergic drugs, or serotonergic drugs, or antihistamines, or GABA-related drugs to do certain things in this umbrella of arousal. But there is only one neuropeptide that interacts with every arousal mechanism in your body, and that is orexin. And so this is why orexin research is so important at looking at deficiencies in orexin, neuropeptide, and orexin receptors has been tied to excessive sleepiness syndrome, such as narcolepsy. And so agonizing those will help us stay awake. But as I mentioned earlier, I told you, I said, we can antagonize this. We can block this. And what do? We shut down all of those. So we can increase the desire for sleep by antagonizing. But what happens when I said the original research was to agonize this? What have we just done? Man, we have jacked with every area of arousal and every neurochemical in our brain that deals with arousal mechanism. So again, as I said, drugs are not smart. So we haven't yet figured out how to target one area and not all of the other areas. I was actually involved in the clinical research for the very first orexin drug. And it was an orexin agonist. And that trial got stopped really fast. So, but you can see from this pictorial representation that all of those same neurochemical areas that we talked about, and all of those same neurochemicals that are involved in reward pathway are involved in arousal. Yes, sir?
What were the biggest reasons they shut it down? What were the most common adverse effects that were showing up that made them stop?
Neuropsychiatric or psychiatric effects.
Okay.
Because what was happening is you're overstimulating here, you're overstimulating here, you're overstimulating here, and so the psychiatric side effects were just unbelievable. And so that's the problem is that you didn't really want to be over-activating those, and they just couldn't figure out chemically how to not do that. So orexin and behavior. This is a really neat slide, putting all of it into perspective at how important this little neuropeptide actually is, and how sleep and circadian cycles and stress and other biological processes such as hunger have a relationship to orexin. And then once orexin is released, how it targets different nuclei, and then what is the result of that, and what are the behavioral effects of that. So in the whole neurobiology of addiction, I firmly believe that this is one of the untapped areas that they're going to have to go back and look at, because all of these other things over here, these input signals, can all be affected in those folks that have substance use related issues, or deal with the reward pathway. And look down the line, where are we at? We're with our orexins, or our hypocretins. Uh-oh. Oh. Okay. So, orexins, what are they? They're a small cluster of neurons in the lateral hypothalamus. They're released during wakefulness and they promote arousal. They enhance motivation and reward. Yay. We've already talked about those pathways. So, if we antagonize orexin, we can reduce drug-seeking behavior. So you just thought I was doing some other dumb lecture. It all ties back into the very first one. So these chemicals, these peptides and these receptors that have to do with the sleep-related disorder all tie back into our reward pathway, because sleep is a basic biological process that still interacts with the reward pathway. So orexins regulate REM sleep. And switching between REM and non-REM sleep is stabilized by orexin peptides. And that's important because we have a deficiency in orexin peptides and receptors in narcolepsy patients. So what happens? We destabilize those state boundaries, and that's why the diagnostic criteria for narcolepsy is seeing sleep onset rapid eye movement in those naps. Because you're not allowed to stabilize that whole system. You destabilize it because we just don't have enough of it there. And so these patients are popping into REM sleep. And these are patients that will tell you when they nap, they dream. And this is a hallmark for patients that are jumping into REM sleep. The other thing is that because the system is destabilized, it's not uncommon that narcolepsy patients will complain of or report to you sleep paralysis. So when they wake up, they have the inability to move, but they're consciously aware. And that's because it's a state boundary issue. Again, the system is unstable, and so you're coming out of REM sleep very rapidly into consciousness, but your muscle tone is not caught up yet. So you have this paralysis that's happened momentarily. You can also have what are called hypnagogic or hypnopompic hallucinations. So hypnagogic are hallucinations that start early in the evening with sleep onset. Hypnopompic are hallucinations upon waking. So G earlier in the alphabet, earlier in the night. P later in the alphabet, later in the night. That's how you remember those. Hypnagogic, hypnopompic. Again, you have a REM destabilization that's going on, so this brain is being allowed to pop into or out of a movie without the rest of the brain's activity systems to be caught up. So these may be patients that are having a dream state awake at the beginning of the night or when they wake up, because their entire system of REM is destabilized. And we think that's due to orexin peptide deficiency and or orexin receptor deficiency. Animal studies, we talked about the gene found in the canines, the Dobermans, and then there's mice that we can actually use knockout mice, and we can knock out their orexin peptides and make them narcoleptic, and then there's goats that are narcoleptic. So we know that in human studies, we can measure orexin in cerebral spinal fluid patients. It's just that this isn't a perfect science yet. You can have narcolepsy patients that don't have significant reduction in orexin circulating neuropeptide. We don't know why that is. There's also a HLA marker that can be looked at in narcolepsy patients. So it's like HLA-DQ, so it goes on forever. But you can do HLA studies on patients, but it's not an exact science either. You can have an HLA positive patient that doesn't have narcolepsy, and you got a narcolepsy patient that's not HLA positive. There's only a couple of places in the United States that will actually do HLA testing, and Stanford is one of them. Patients have to undergo a spinal tap for them to do this. So just for a diagnosis of narcolepsy, I'm not sending somebody to Stanford for a spinal tap, because it's not really going to change what we're doing. We're going to treat their excessive sleepiness. So HLA, there it is, DQB asterisk 06:02. You'll never remember that, but neither will I. See, I told you. I said DQB, didn't I? So, there's multiple theories as to how excessive sleepiness syndromes can present. There's a dual bell curve that happens. We see it in 18 to early 20s, middle 40s to early 50s. Those are the two big curves of where we see it. More commonly in men or women. Get a 50-50 shot. Women. So I will tell you, the most common group that presents are young females in their early 20s. Very commonly, these people will have been exposed to a significant viral illness. Epstein-Barr mononucleosis, viral meningitis. So in your history taking with somebody that has a excessive sleepiness set of symptomatology, you're going to want to ask them about head injury or significant viral illness as a child. Because there are some theories that we can have neurodegeneration as the result of a viral illness that kills the receptors and or the peptides. There is some other theory that damage because of head injury can lead to, and then there's also some other fancy genetic stuff that it'll take forever to figure that stuff out. So we've talked about what happens when we have a loss of erections in narcolepsy. This was a erection replacement study that we kind of started. We were a part of this. It was a worldwide study. They were actually doing it by intranasal. You don't have to know that, but so since we're doing psychiatry, there are connections, we think, to erection deficiencies in psychiatric disorders. Why? Because I showed you earlier that erection projects to all of the main areas that deal with all of the main neurochemicals that have been found to have a relationship to mood disorders. And so we think that orexin has a role in the treatment of neuropsychiatric conditions, but we just don't have the drugs available to us yet. Why? Because when we deal with that one slide with all the orexin, we deal with not only serotonin or not only norepinephrine or not only dopamine, we're dealing with acetylcholine and histamine and all kinds of other things. So we know that there can be a tie to psychiatric disorders. We know that other neurological disorders can have some relationship. So there was a small study that attempted to look at Guillain-Barré, and there's a deficiency in orexin. So again, you're dealing with a viral illness that has potentially caused some damage there. We know that injury, as I mentioned before, head injury, something of that nature, that there's been studies that show that that can produce lower CSF levels of erection. Relationship to insomnia, we know that, as I talked about, or suvorexant or Belsomra is used if we antagonize. These are just a plethora of studies that have been done to look at the arousal system and how orexin deals with that, and you would expect it to based on how it interacts with so many other brain areas. Trying to make sure that we have time for their suvorexant. Yeah, we're good. Okay, I made it. Okay, questions? No, I'm getting some wide eyes, like, holy. You didn't know sleep was so complicated, did you? You think it's just, oh man, grandma can't sleep, give her some Halcyon. Ooh, grandma's good. No? Okay. Thanks for listening. Thanks for Friday afternoon. Yes, sir.
You'll love this. She said, don't, your advice was never use Halcyon to treat somebody. When I was a Ferndale resident, the first thing I ever wrote and published was a case report of a drug interaction between cimetidine, which we hardly use anymore, and Halcyon in a little old lady who was in a dialysis center. I mean, she had a lot of reasons for it to stay around, so she took it, and she's been on Tagamet for a long time. And she had the most bizarre delusions, hallucinations, weird dreams. And we figured in the end that it was an adverse reaction to that drug, which had not been out that long. So we pulled her off, and of course it took her about a week and a half to 2 weeks to get out of her system because it just wasn't going to clear it. But she came back completely lucid, and it was an amazing thing. So that drug does some interesting things up here. She was really driven out.
And cimetidine is one of the drugs that will make a urine drug screen falsely positive for methamphetamine. So you can see then if the body is processing this chemical and it appears fairly close to a litmus assay of methamphetamine, not only is it helping block H2, histamine, it's a histamine 2 receptor blocker for gastroesophageal reflux, what is it actually doing in the brains of these people? And we know that histamine has a large role in wakefulness, because we didn't talk about this. Oh, how did we not talk about this? Provigil and Nuvigil, wake-promoting agents that are approved by the FDA for treatment of excessive sleepiness in narcolepsy, excessive sleepiness in shift work sleep disorder, and excessive sleepiness in patients who are on apnea treatment or still are having significant sleepiness. The theoretical mechanism for modafinil and armodafinil is histamine release in the tuberoinfundibular tract. So if we would have histamine release in the periphery, we would kill somebody if we were giving them a drug to push a bunch of histamine out. But these drugs are thought to increase histamine released in the tuberoinfundibular tract so that we're increasing arousal mechanism, because I can get this. You all want to see the slide again? This is my favorite. This is one of my favorite slides ever. So look up here. The other end. Right there. Okay, so histamine's involved in the arousal mechanism. That's why antihistamines make us sleepy. Okay, so they have figured out with this drug that if we agonize the tuberoinfundibular tract, we can actually keep people awake. And so those are non-amphetamine-based stimulants, but we know amphetamine-based stimulants will also deal not only with histamine, but norepinephrine in the frontal lobes. And so it's interesting that that drug gives us an inappropriate positive for methamphetamine. The other drug that's approved, and I'll quit after this, the other drug that's approved for the treatment of cataplexy in narcolepsy patients is a drug called sodium oxybate, also known as Xyrem. It's a prescription date rape drug. I kid you not. So, roofies or whatever the chemical name is, sodium oxybate given at nighttime will reduce the potential for cataplectic events in patients during the daytime. The problem is that if sodium oxybate is added to, see, date rape drug doesn't do any good unless it's added to alcohol or some other central nervous system depressant. Then it will provide a profound amnesia. So we have to be very careful in prescribing sodium oxybate so that patients are aware, don't take NyQuil, don't drink any other form of alcohol, no red wine vinegar, these kind of things, because it can cause a profound amnesia and be very dangerous. The other thing about sodium oxybate is that because it's dealing with the muscular system somehow, we don't really completely understand it, one of the adverse effects is enuresis and encopresis, and that's not something that a patient wants to really wake up to, that they come in and say, what'd you give me because I just did what in the bed, and you said this is supposed to help me and not make me worse. So it's an interesting chemical. I have prescribed it before. It comes out of a specialty pharmacy in Kansas City. It only comes from one pharmacy. It's controlled by a company called Jazz Pharmaceuticals. Jazz actually has another really neat drug. Did we talk about Prialt when I was here last? Oh, I'll quit after this. So for chronic pain, the FDA has approved a non-opioid substance to go in intrathecal devices, and it's snail venom. And it goes by the trade name Prialt. The thing about snail venom is it's not opiate, so you won't have any withdrawal, you don't have respiratory suppressive effects, these kind of things, but you have significant neuropsychiatric side effects if you get the dose too high. But Jazz also has snail venom. So they've got this collection of drugs which are really weird and highly controlled by the FDA, so anyway, that's enough. And I got you out before 5.
Yes, I love it.
I love the meeting.